Imagine a vast cosmic graveyard floating between Mars and Jupiter, a place where the remnants of failed planets linger in the silence of space. This region, known as the asteroid belt, is a band of rocky debris that never managed to form into a full-fledged planet. But how did this belt of fragments come to be? And why did these planetesimals fail to unite into a world of their own? Let's dive into the mystery of the asteroid belt and explore its role in the solar system. What is the asteroid belt? The asteroid belt is a region in space that lies between the orbits of Mars and Jupiter, about 329 to 478 million kilometers from the Sun. It contains millions of rocky bodies, ranging in size from tiny pebbles to massive objects hundreds of kilometers in diameter. These rocky objects are called asteroids or minor planets, and together they make up what is essentially a zone of failed planets, objects that, billions of years ago, had the potential to form a larger world, but never quite made it. The total mass of the asteroid belt is surprisingly small compared to Earth or the other planets. In fact, if you combined all the material in the asteroid belt, it would only form a body about 4% the size of the Moon. So why, in a solar system that has produced planets as massive as Jupiter and Saturn, did these pieces of rock never manage to come together and form a planet? The early solar system, a time of chaos. To understand the asteroid belt, we need to go back about 4.6 billion years, to the time when the solar system was just beginning to form. Back then, the Sun was surrounded by a massive cloud of gas, dust, and ice, known as the solar nebula. Over time, gravity caused clumps of this material to coalesce, forming planetesimals, the building blocks of planets. In most regions of the solar system, these planetesimals collided and stuck together, eventually forming planets like Earth, Mars, and Jupiter. However, in the region between Mars and Jupiter, things didn't go according to plan. The reason? Jupiter's massive gravitational pull. How Jupiter stopped a planet from forming. Jupiter, the largest planet in the solar system, has an immense gravitational influence on its surroundings. In the early days of the solar system, as Jupiter formed and grew larger, its gravity disrupted the material in the nearby region. The planetesimals in the area that would become the asteroid belt were caught in a gravitational tug-of-war. Instead of gently coming together to form a planet, the planetesimals in this region were pulled apart, their orbits disturbed by Jupiter's powerful gravity. Some were flung out of the region entirely, while others crashed into each other, breaking into smaller pieces. The result was a chaotic environment where the formation of a planet became impossible. In essence, Jupiter acted like a cosmic bully, preventing the planetesimals in the asteroid belt from peacefully merging into a single world. Instead, they were doomed to remain as fragments, pieces of rock and metal that would never become part of a planet. The asteroid belt today, a diverse collection of objects. Today, the asteroid belt is home to millions of individual asteroids. Although they may all seem like lifeless rocks, the asteroids in the belt are incredibly diverse in composition, size, and shape. Some are rich in metals like iron and nickel, while others are made mostly of carbon-rich materials. There are also asteroids that contain water ice, hinting at the belt's complex history. Ceres, the largest object in the asteroid belt, is a dwarf planet. At about 940 kilometers in diameter, it contains roughly one-third of the asteroid belt's total mass. Ceres is unique because it has enough gravity to pull itself into a round shape, unlike most asteroids, which have irregular, jagged forms. Scientists believe that beneath Ceres' surface, there may even be a layer of water ice or a subsurface ocean, making it a fascinating target for future exploration. Other notable objects in the asteroid belt include Vesta, Pallas, and Hygeia, each of which is hundreds of kilometers in diameter. Vesta, in particular, has been of great interest to scientists because it shows evidence of past volcanic activity, suggesting that even in the asteroid belt, some objects were once geologically active. Asteroid collisions, a violent past and present. The asteroid belt may seem like a peaceful place, but it's actually a region where collisions are common. Over billions of years, asteroids have smashed into each other, breaking apart and sending debris flying in all directions. Some of this debris has even made its way to Earth in the form of meteorites, small fragments of asteroids that survive the trip through our atmosphere and land on the surface. These collisions have played a crucial role in shaping the asteroid belt as we know it today. Many of the smaller asteroids are likely the remnants of larger bodies that were shattered in violent impacts. In fact, scientists believe that some of the larger craters on the Moon, Mars, and even Earth were caused by ancient asteroid impacts. One of the most famous asteroid impacts in Earth's history occurred about 66 million years ago, when a 10-kilometer-wide asteroid struck the planet, leading to the extinction of the dinosaurs. This asteroid, known as the Chicxulub impactor, may have originated in the asteroid belt, making it a reminder of the potential dangers that these rocky bodies pose to life on Earth. The future of the asteroid belt. As we look to the future, the asteroid belt remains a region of great interest to scientists and space agencies. Understanding the composition and history of the asteroids could provide valuable insights into the early solar system and the processes that led to the formation of planets. In recent years, several missions have been launched to study asteroids up close. NASA's Dawn mission visited both Vesta and Ceres, providing detailed images and data about these two massive bodies. Meanwhile, the OSIRIS-REx mission successfully collected a sample from the asteroid Bennu, which will be returned to Earth for study. These missions are helping us unlock the secrets of the asteroid belt and its role in the solar system's history. There is also growing interest in the potential for mining asteroids. Many asteroids contain valuable resources, such as metals and water, that could be used for space exploration or even future colonization efforts. By extracting these resources, we could reduce the need to launch supplies from Earth, making long-term space missions more feasible. A window into our past. Ultimately, the asteroid belt is more than just a collection of space rocks. It is a window into the past, a glimpse of the solar system's chaotic beginnings. The asteroids that orbit between Mars and Jupiter are the leftover building blocks of planets that never were, shaped by the powerful forces of gravity and time. By studying the asteroid belt, we gain a deeper understanding of how planets form and evolve. We also learn about the delicate balance that exists in the cosmos, where the gravitational influence of a giant like Jupiter can determine whether a planet is born or destroyed. In the grand scheme of the solar system, the asteroid belt may seem like a small and insignificant region, but it holds the key to understanding some of the most fundamental processes that shape the planets we live on today. And as we continue to explore this cosmic graveyard, who knows what other secrets we may uncover.